So what we are going to do next is that there were null values present in our data frame. Instead of treating those null values, we have directly dropped those null values using drop_NA function. So using this function, wherever there is a null value present in our data set, this function directly works on the null values. Means it will remove the null values. So and then again, we have to check if there are any null values present in our data frame or not using the function df.isNull. So see here, in each and every column the number of null values is 0. So means there are no missing values in this data frame. And then again we have displayed the column names, and wherever we found a particular column which is not of any use, we have to drop such columns as well. So using this command we are dropping the columns. So here I'm dropping the column movie IMDb link, color, title, face number in poster, plot keywords, actor 3 name, movie IMDb link, aspect ratio, and languages. So using this command I am dropping all these columns. Next, let us check the data frame. So this is our data set. So this is the resulting column. Now this is the resulting data frame. Earlier we had 28 columns, but now we have dropped 8 columns, and now the resulting data frame is with only 20 columns and 3756 rows and 20 columns. Now the next thing that we have done over here is a shape of our data frame. So that is 3756 rows and 20 columns. So next we have done over here is we have done the label encoding. So as I told you earlier, the label encoder will convert all the categorical data into a numerical value. So and we have selected some columns like content rating and the director name, genre, actor 1 name, actor 2 name, and country, and we have applied the label encoder on these columns. And now if I check the director name, so it is of int type. So the actor 2 name is also of int type. The genre is also of int type. So like that. Next we have applied a distribution plot. And what does this distribution plot does is that it will show us the distribution of our data and tells us if our data is skewed or it's normally distributed. So we do it with the help of visualization, and as you can see here, these are the total number of rows and columns, and n rows is equal to rows, n columns is equal to columns, and the figure size is 20, 20, and we have given our index as 0, so it would begin from the starting of column and present in the data set. And as well as this is a tight layout that we have given, and as you can see here there is a skewness in our data, and as you can see here we have a skewness in our data set. So there are often columns like actor 1, actor 2, gross, which are skewed, and this skewness has to be fixed, and we do it with the help of a log transformation. So using log transformation, we try to convert the data or transform the data into a normal distribution and reduce the skewness. And as you can see, we have set the column names again. So these are the column names again, and we have saved these columns. So we have a transformation like color name is another cell, and we have put them in a list, and we have given these list names as a skewed features. So here I have applied log transformation to these skewed features. So the entire data has been log transformed, and after the log transform, so the entire data has been log transformed, and after the log transformation, this is the resulting distribution. So as you can see now, the skewness has been reduced and the data has been distributed better as compared to the previous one. So this skewness has been removed. As you can see, when it comes to the selector names, previously it was looking like this. Actor name, it was like this. And now you can see it is distributed properly. So well, we have tried to change our data to our normal distribution, as you can see already in the plot. And the next thing that we have done over here is we have to split our data into independent and dependent columns. So as we know that IMDb score is our target column, we have dropped it from X, the X column or the independent column, whereas the Y is the target column or the dependent column. And we have visualized, we have seen the X dot head. Next, Y dot head. The next thing that we have to do is we have to split our data into train test dataset. So here the test size that I have taken is 0.2. It means that the train dataset is going to be of 80% size and the test data is going to be of 20% size. So you can change the value from 0.2 to 0.3. If you change like that, then the train data will be around 70% and the test data will be around 30%.